Hello again, Math 2, 7th graders. Flip it around. So this is going to be from Lesson 7-3. I'm on page 367. This is about experimental probability. And this is past tense. Either you did the experiments and you're talking about the results, or you did the survey and you're talking about the results. So it's past tense. It's what did happen. Past tense. So a probability of 0 means it never happened. That's what it means. Not impossible, it just means it never happened. And then a probability of 1 means it happened every time, past tense. And that's a difference between theoretical probability. Experimental probability, you can end up saying, if you get, like say you flip a coin twice and you get heads and heads and you say, oh, it's impossible to flip tails, well that would be a silly conclusion to make because you just didn't do the experiment enough. So that would be a nice, clear, extreme example of being careful with experimental probability, the results that you end up saying. So you want to do the experiment enough, or you want to have enough people in your survey so that you can have confidence in the results that you get, right? Don't just do the experiment a few times or just have a few people in your survey, right? So again, so you can pause, but anyways, past tense. So let's get into this. We're just gonna do problems 4 through 10 together here for notes. So say you flip a coin 20 times and they just kept track of the results here. Now the theoretical probability of heads would be theoretical, underline that, would be 1/2. You know, half the time you should get heads, or half the time you should get tails. Now, what's the experimental probability of heads? Well, here I'm going to write probability is winner out of total. Or here you can do probability is winner out of total, and the probability is just going to be 1 out of 2. You don't have to flip the coin on theoretical. You use 1 heads out of 2 sides. But now here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 times you got heads. So it's 11 out of 20, which would be 55%. Anyways, the experimental probability is, I'll say 55%, because you can go times 5 times 5. The experimental probability is greater than the theoretical. And it's not the same. The only reason it's not the same is because you only did the experiment 20 times. If you did it like 20 million times, you'd get pretty close to 10 million heads and 10 million tails. When you do the experiment a whole bunch of times, as you do it more and more times, your experimental probability will get closer and closer to your theoretical probability. Did you hear me say that? So as you do the experiment more and more times, your experimental probability gets closer and closer to your theoretical probability. Number 7 here. So say you've spun the wheel 80 times and here's your results. Well, you should get 20, 20, 20, 20 if it's a fair spinner, right? Your probability is winner over total again. Well, it's going to be 18 over 80, which reduces to 9 over 40, which is like 4.5 over 20. And if you go times 5 times 5, that'd be 22.5%. So that's kind of tough to get. But again, probability is winner out of total. Right? Same formula, but it's, this is past tense. You actually did the survey or did the experiment. Liz flips a coin 50 times. What's her theoretical probability it's going to be heads? Well, that'll be 1/2. Now, what's her experimental probability that it was heads? Well, probability is winner out of total. Heads was 20 out of 50, which would be 2/5, or you could say 40%. The theoretical probability is greater than the experimental probability. And the reason they're different is because you didn't do the experiment enough. As you do it more and more times, they should get closer and closer to equaling each other. Number 9. So here, Jess spins a pointer 25 times, and the experimental probability of the pointer landing on 3 is 4 out of 25, which is 16%. The theoretical probability should have been 25%, 1/4. So there must be 4 equal sized sections, probably like 1, 2, 3, 4. So why are these different? And it's because you didn't spin it enough times, right? Okay, I'm not going to write that out. And number 10 here, that book actually made a mistake here. If you surveyed 100 people and these were the results, what's the experimental probability of going to City E? Well, all these should add up to 100, and they add up to 102. So I just changed that one to 26. Here's 60 plus 40 adds up to 100. So anyways, what's your experimental probability of going to City E? Well, probability winners out of total, that'd be 8 out of 100, which is 8%. Which is 8%, right?